Thanks for everyone coming to the session, and let's get started. Again, thanks for having me here at Vox Day Ticino as well. It's a wonderful place to be at this very moment, so it's awesome. And my name's Ray. I'm a developer advocate for the Google Cloud Platform. What that means is I like to bring some of our technologies to developers all over the world, whether it's Google Cloud or open source like Kubernetes, ECO, gRPC, and such. But my other very important job is to help to make the experiences better for developers as well. And so for that, I need to help the products team to understand what it is that specifically what Java developers need. And one of the things that I started maybe almost a year ago with an engineering team at Google is a project called Spring Cloud GCP. And that is the project I'm going to talk about today. If you have any questions, please feel free to contact me on Twitter at Satanism, direct message or whatever. That's probably the best way to find me. And for any of the materials that you might want to find, you can check out my site on satanism.me. So let's get started. So this talk is going to be oriented around some of the things that you can do on GCP. And there's definitely a lot of things you can do, anywhere from running virtual machines to platform as a service that's completely managed for you, to running stuff in Kubernetes, to machine learning, to big data. We just got some really amazing technology. I'm not going to go through every single one of them today, don't worry. But to make that experience better for Java developers, there's a lot of the things that we're working on to help with that. So for example, really good framework integration with Spring and Spring Boot, good IDE toolings with IntelliJ and Eclipse, really easy way for you to deploy your apps. And most importantly, that most of the people overlook is that after you deploy the app, you need a really good way to monitor and being able to debug issues and track down production issues so that you can keep your applications up and running. And so today, what I'm going to show you is just a little bit about how to get started and how to use some of these toolings, and also some more unique things that you might actually find helpful. Now, one of the goals that we set out to do was to basically make one of the best experiences for Spring and Spring users to be able to integrate with Google Cloud Platform services. Now, just a show of a hand, any Java developers in the room? Yeah, everyone. Okay, good. Using Spring and Spring Boot? Yeah, just about everybody as well. Yeah. So one of the goals here is to help you cut down the boilerplate that you might otherwise need to write a lot. But using Spring and its auto configuration constructs, we were able to automatically configure a lot of things by convention over configuration, right? And we actually worked pretty closely with the Pivotal engineers too to make this whole experience idiomatic. Today, what you can do is a lot of these integrations you can just get right off the bat from the project called Spring Cloud GCP. You can just add the starters, and we have integrations across multiple hosted services. The idea here is that as a developer, I really just want to be able to write the code that deals with the business logic. And I also want to be able to deploy things into production directly, but without having to worry a lot about the production configurations. When we're in a cloud-native world, when you are actually taking full advantage of the cloud, what you are going to see is that all the toil that used to happen around how do I configure a really scalable instance of something, whether it's a cluster of Hadoop or a cluster of whatever else, all of those kind of tiny things will be taken away. You don't have to really worry about that anymore because they will become a managed service that you can just start to utilize. Right? And you can get started really quickly to build interesting things. Without further ado, I'm just going to go and show everything in the next 40 minutes. So this is the thing I'm going to try to do. We're going to start a new microservice, which is an application, whatever that you call it. We're going to connect it to maybe a globally available database that will be spanned across the world. And then we're going to add tracing and logging to it so that you can actually debug and have full visibility into your application. And we're going to deploy it into a production environment, both Kubernetes and App Engine, platform as a service. And we're going to see what else we can do in this kind of environment, right? So to get started, the first thing that we do is, of course, I'm going to generate a new project. For this project, I'm going to use Kotlin just because it's nice and simple. I'm going to use the latest version of Spring Boot. So you can generate whatever you want from this Spring initializer, but the most important thing that I changed here is by adding the GCP support. So just by adding this starter here, we will add GCP support into your application, and we're going to see what that looks like in a second. Okay, so I'm going to go ahead and start this new project. Going to create just a new service here. Pretty simple and straightforward. There's nothing really special about this service at this very moment, except for that in the pom.xml, when you generate this new project, you can see that not only do we have a Spring Cloud version here, we got the Spring Boot version here, but most importantly, we also added the Spring Cloud GCP starters. So this is actually a set of dependencies that you can add to your projects that will then automatically configure your application to consume some of the services on Google Cloud. And once you are doing that, what you should be able to see is that, first of all, you're going to be able to write idiomatic Spring code because we worked really closely with them to make sure that this experience is really awesome. And secondly, again, for a lot of the things that we tend to do that we may have to wait for another team to provision infrastructure, those things can be done by developers simply by kind of configuring what it is that we need. So why don't we just get started on this one? So this is a pretty simple and straightforward app. And this is, in fact, a Kotlin app. So there's nothing in here at this very moment, just a very simple run. And why don't we go ahead and do something pretty simple that everybody does, right? So for example, in order to, if you want to use like anything with SQL, like Cloud SQL, or use PostgreSQL or MySQL, to use a managed service, sometimes it means that you need to find the IP address, you got to configure the credentials and all that. But on GCP specifically, what we can do is, of course, provision a new Cloud SQL instance if you want to. And to do that, we can go here, and there's SQL, right? Now, from here, of course, you can provision a highly available instance if you want to. There's really not additional configurations you really have to worry about. You can configure, for example, the maintenance windows and all that. But what we're going to give you at the end of this is an instance where you have an IP address. You could get a public IP, or you can get a private IP. But if you want to connect it from outside of the cloud, like from another cloud for that matter, or maybe you're running this on-prem, then you really need to go through the public IP address, right? Because you are not on the same network. However, if you do it this way, what you end up doing is that you need to whitelist your source, your consumers, so that you can actually connect to this particular instance. And to do that, you have to whitelist the IP. But in most cases, you're not going to know the IP address that you're making the call from, especially if you are in another cloud environment where the IP address is changed and you just don't know what the range will be. In that case, what you want to connect with is a instance connection name, right? For example. And basically, behind the scenes, we made all of these connections pretty simple and straightforward. If you want to connect to a SQL database, for example, we can go ahead and add a starter here called the SQL MySQL starter. Basically, what it does is to include the right versions of the driver, and also in order to make this connection in a secure manner, we actually need to configure your JDBC driver with a special thing called the SSL socket factory. What that will do is to authenticate against the cloud services and exchange an ephemeral certificate for you behind the scenes, and using that certificate to make a secure connection to this instance while it's authenticated as the user. Okay. Now, how many people here love to deal with custom certificates in Java? Yeah, that's what I thought. Nobody. Yeah. So that's okay. You don't have to worry about it. So basically, by using this starter, we take care of everything for you, right? That's just the basics, right? And if you do use the starter, typically what you want to configure with the JDBC driver is the JDBC URL. But specifically, if you want to try to connect in this particular case, we actually have just a really straightforward application properties here. So you can just give it the instance connection name, which you grab from the console, right? And then you can give it the database name, which I already created, which is called people. What this will do is to automatically construct the right JDBC URL for you, attach it with the SSL certificates that's necessary to make that connection securely to the Google Cloud environment. And while this is happening, you can still go ahead and use all of the other Spring-based properties. So for example, I want to make the Hibernate DDL to be auto-update. Maybe I want to limit the connection pool size to 2, right? We can do all of these things if we want to. And of course, on the code, environments, right, you can do whatever you want here. So let me just go ahead and write something pretty simple and straightforward. So I'm going to use Kotlin here. I'm going to use a data class. I'm going to call it person. And of course, you can annotate this with entity. You can annotate this with ID. And of course, you can do a generated value, right? You can do the strategy is equal to, oh, I don't know, sequence. Let's do that. And then you can make your data repository if you want to, which I'm going to do right here. Let me see here. The type here will be long, right? And there's nothing new here. This application will probably start, hopefully. And if it does start, it should show you the connection that's going to be taking place. So let me give it a try. I just created this just now, but let's see if this works. How many people think this would just work? Nobody. Wow. Good crowd. Oh, there we go. So you see how here, when we started this application, it says we're obtaining an ephemeral certificate from the Cloud SQL instance. This is happening also because we also have installed gcloud command line locally on the computer. And with that, we are automatically authenticated. I actually had to authenticate first, but once I authenticated in my client on my CLI, this credential can be propagated down to the application that you're developing locally on your machine. And so basically what happened is that the reason why this is happening is because of this JDBC URL that's been constructed. So you can see here in this URL, there's no reference to the IP address. There's only a reference to the instance connection name. And we give you a very special socket factory here that basically takes the JDBC URL and establishes the SSL connection behind the scenes. And now you're connected to Cloud SQL in a secure manner, right? And we can give it a try if you want to. It doesn't work unless if I show you that it's working. So I'm crossing my fingers, right? Of course it works. Yeah, not bad. This is just connecting to the SQL database. There's nothing new here. I think a lot of people do use, the entities and stuff, and maybe some repository to help you orient and just being able to connect and do some data manipulations in the SQL database. Now, I don't know if some people would have some issues with their database where maybe it is running out of space, or maybe that you need a higher transaction rate, higher QPS, or more specifically, maybe for some organizations, they really need an application where they can scale globally, right? They want to be able to scale globally around the world. They want to go to Asia, go to Europe, go to America. In typical relational database setup, you are limited to a single zone or a single region. If you're on a very high-speed network, you can be in a single region and maybe fail over across multiple zones. But if you really need to have a globally available database, then you have to look for some other solutions, right? You need something that's horizontally scalable, but typically what that also means is that maybe it's not transactional, right? Because of the CAP theorem, if you are horizontally scalable, where you have partitions, then maybe you don't get the consistency. Now, specifically on Google, on the Google Cloud Services, what we do have is this thing called Cloud Spanner. I don't know how many people here heard about Spanner before? Maybe one person, wow, two. So with Cloud Spanner, the best way I can describe it is that if you ever need such a use case where you don't want to deal with, say, I know some people who have like Cassandra where they can have really, really fast write and horizontally scalable. But then as soon as you need transaction, all hell break loose. You got to write your own transaction layer, right? So with Cloud Spanner, it is a globally distributed, horizontally scalable, strongly consistent relational database. Okay, so all of those things don't really go into the same sentence usually, but we're able to make that work in Cloud Spanner. So basically, whatever you write across the different zones or different regions, they will be strongly consistent across the world once you write it. If you need to have more data, more like QPS, all you need to do is to potentially scale out your database and say, I need an additional node. In Cloud Spanner, we'll actually manage all of the sharding for you behind the scenes, so you don't actually have to deal with any customized sharding. We'll just take care of that for you as well. It's a relational database. What that means is that you can actually use SQL. So we do have a JDBC driver as well, so you can just use SQL if you want to take full advantage of Spanner. Now, of course, if you already have an application, how are you going to take advantage of such an advanced database? You don't want to rewrite the API and all of that. So for that matter, what we can do is that we actually work really hard to create a new Spring Data integration here. So rather than using SQL, if you don't want to, or rather than using MySQL or Postgres, you can basically take away some of these dependencies. And if you want to use Spanner just for fun, and or your business actually needs it, what you can do is to add the Spring Data Spanner starter instead. So for that, we can add this right here. So we can add this thing called GCP starter data spanner, and that will get you Spring Data integration directly into the Spanner database. Now, because it is a SQL database, but it is horizontally scalable, what that also means is that there are a few things that we have to change. So for example, for the longest time, I think people have moved from a composite key, kind of like a primary key where you have 2 or 3 different keys that compose into a primary key, into a surrogate key model where you just have a sequentially generated ID. However, in a globally distributed system where you do need to have high throughput, you cannot really rely on an auto-generated ID, right? Because if you're generating IDs sequentially, then you're not going to be able to have the throughput that you need, because then you need to have locking across the world in order to understand what the next ID is. So for Spanner, for example, for Cloud Spanner, rather than using sequentially generated ID, we don't recommend that at all. And also, we do not recommend any monotonically increasing ID because that is not great for sharding. So specifically, what we do recommend is UUID. And for that reason, for the ID, we typically use a string to represent a UUID instead. Okay? And rather than using the JPA entities here, we actually made the starter specific to Spanner, so you can actually take full advantage of the database. Just like there's Spring Data for Mongo, Spring Data for another database, this is one specific to take advantage of a globally distributed database. And so for that matter, rather than having a surrogate key, you need to specify the primary key yourself. And also, if you actually have multiple columns that you need to use as a primary key, you can do that with Spanner as well. And this is necessary for a parent and children relationship. You do need to have composite primary keys. And all I need to do here is potentially change the type of everything that I have already created. So rather than using alone, I'm going to use the ID. Rather than using entity, I'm going to use table. Rather than using add ID, I'm going to use primary key. And let me just get rid of some of these things on the top. And that should do it. This will help you migrate potentially your data object to Spanner. This is a very simple example, but relationships and all that is more or less supported as well. Okay. If I want to create a new database here, then I do not need the SQL database here anymore. Rather, I'm going to use the Spanner configuration. And again, this is all something you can do directly with Spring's application.properties. Right? So here I can specify the instance ID, and then also I need to specify the name of the database. Now, I may not actually have a Spanner database I need to use right now, so I'm going to create one right now. So just for fun, I'm going to go ahead and go to Spanner here, and I'm going to just go ahead and create a new database. And this is how easy and simple this may be. So I'm going to code this the Ticino database. Yeah, there we go. And this is going to be the name of the instance. And all I need to do is to specify whether I want a regional database, which will be scalable across the zones, or a multi-regional one, which will be scalable across, North America, Europe, and Asia. Okay? And we're going to run one node each, and I'm going to go ahead and create this instance. Because Spanner is actually a hosted environment, what that means is that we actually do not provision VMs behind the scenes. There's no waiting for the database to come up. All I need to do is to say I need an instance, and I get an instance just like that. And then I can go ahead and maybe create a new database called people if I want to. So here's the people database. I can add a new table. I'm going to call this person table because that's the one I'm going to map to. And then I can add an ID here. And remember, we wanted to use a UID, so I'm going to use a string. So I'm going to set that to 60. I'm going to set this to a primary key, so it's not null. And similarly, for the name, I'm going to create a table for that. A column. Of course, if you don't like to go through the UI every single time somebody asks you to create a new database, you can also use the DDL if you want to, okay? So you can use the command line interface to do that. And then we're just going to go ahead and set the primary key column and go ahead and create. And just like that, you get a globally available, horizontally scalable database that is strongly consistent supports transactions and all that, which is pretty amazing if you ask me. Now, if I want to connect to it, right, I come back here. If I set the instance ID, let me see what the instance ID is. I can probably find it. It's oh yeah, it's called Ticino, right? So I'm going to go ahead and do Ticino, and the database name is people. And if everything works, I should be able to restart my application and see that this is now connecting to the Spanner database instead. Okay, this is a brand new database. I just created it, and there should be no data inside. Okay, and as you can see, because it doesn't really need to connect to the SQL database at all, this connecting to this managed service is pretty quick, and we can start up the application very quickly too. All right, so to see if everything works, I'm going to go ahead and curl the persons again. Now, we actually implemented not just the Spring data repositories, we also implemented whatever mapping that's necessary to get it into a REST resource. What that means is that when I'm making this call to persons, this is exactly the same as what otherwise you would get from a SQL database. So you can use a Spring data repository for REST if you want to. And as you can see, my Spanner database has no data in there, okay? Or maybe it's just not working. You don't know either one. So to prove to you that everything's there, what I'm going to do is to do a post. So I'm going to do a post here. I'm going to use the person's endpoint to do a post. Of course, because we do not generate the ID for you, you do need to give it the ID yourself. And I'm going to just go ahead and give it a name. I'm going to say Vox de Ticino. I'm going to post it directly into the endpoint, and hopefully this will write the data to Spanner behind the scenes as well. And of course, we made it really easy to do just that. So I'm going to go to the SQL query here. I'm going to say select star from person. Oh, that's not star from person. Right, because sometimes people will tell me, Ray, that seems a little fake. Like, what if it's just an in-memory database, right? What if it's just not really going to the database? So to prove to you that it's actually there, I actually have to make this query. Oh, wait, what? Sorry, typo. Whew, that was scary. And to prove to you that everything works, of course, you can see the data right there, right? And of course, if you go back to the person's curl, we should be able to see this data as well, right? Pretty simple and pretty straightforward. Really, really nice and easy integration that the team has done. I'm really proud of the team who really work hard to make this idiomatic experience. But we can do even more, of course. Let's suppose we're actually having a microservice environment where we are making multiple calls from one call to another. Then what do we do? Well, to simulate that, I'm going to go ahead and first create a little hello world endpoint here. As you can see, I made this really, really quick. I have a live template behind it. So we can make this hello world controller very quickly. I'm going to say hello here. And of course, what I can do is I'm using Kotlin right now, so I'm going to use a private val, private final variable here. What I'm going to do is to automatically inject the person repository into my application. Person repository, yeah, there we go. And then whenever I receive a name here, I'm going to say person repository, and I'm going to save a new record, right? So I can say this is going to be a new person. I love Kotlin. And remember, for the ID, we need to use auto-generate ID. We need to use UUID. So luckily for you in Java, the UUID class is actually UUID v4, which is the UUID generation that we do recommend for Spanner as well. So for the ID, I can set the ID here. And for the name, I'm going to set the name. And that's it. And every time I call hello and with the name, I should be able to write the data to the database. But we're going to go a little bit further. I'm going to simulate a call from one service to another, just for fun. Right, so for that, what I need is a REST template. So I'm going to go ahead and provision a bean for that. So here I'm creating a new REST template, making that into a bean. And then what I need to do is to maybe make multiple calls. So I'm going to not bore you with the code, but let me just do this very, very quickly. I need to inject my REST template into here. And then what I'm going to do is to iterate through a couple of names, like Ray, that's me, Mandy, my colleague, and Jisha, who also works on this project. And then for every one of these names, what I'm going to do is to make the call to the local hello endpoint, and I'm going to say hello to those people, and then you should be able to see the data being written. Now, that's not very interesting, but what it will be really interesting is to be able to add tracing to it, right? Distributed tracing, so you can actually see who is actually making the call and such and such. Now, in Spring, the way that you would add this is by using Spring Cloud Sleuth. If you add Spring Cloud Sleuth dependencies into your application, you get distributed tracing right off the bat. It's going to help you capture the incoming trace headers, and it's also going to help you propagate the trace headers via the REST template. But by default, Spring Cloud Sleuth is going to send the data to Zipkin, for example, or something that you have to host yourself. And we did work with the Zipkin team to actually add a Zipkin sender that can send it directly to Google Cloud if you want to have a hosted service. So in case you don't want to host your own trace server, in case you don't want to worry about how much data you can actually store, then you can choose to use a hosted service instead. And we do have an auto configuration for that, if you want to do that, which is the trace starter. So by adding this starter, what you get is Spring Cloud Sleuth, the original one, and then we'll automatically configure the exporters to export data to Stackdriver into Google Cloud Platform. But what will be even more interesting, though, is to actually capture the logs. So in most cases, you may want to have centralized logging. In different environments, the way that you capture the centralized logs are different. So for example, if you're running on a VM environment, maybe you want to capture the log from an agent like FluentD. If you're running locally, or if you're running an environment that doesn't have FluentD, then maybe you want to log directly via the API to the centralized logger. If you're on Kubernetes, what you really want to do is to export the log via JSON format. Okay? Because in Kubernetes, what you want to do is to export the log always via std out or std arrow, so that the centralized logger agent in Kubernetes can pick up the logs. However, to add metadata into the logs, you actually need to format it specifically with additional attributes. So a typical line here, like this one, right? Yes, this is a log message, but unless if you know how to parse it, it's going to show up as a single line of log message, right? So we made that also very simple for you to do. So for that matter, we can add a little log configuration here. Like in Spring, what you do is to do the logback spring.xml, right? And in this logback.xml, we can add a little configuration. Oh, where did it go? There we go. So there are a couple of things we can do. First of all, you can include a log appender definition here. And then you can just use one of the appenders that we created for you. This is called the Stackdriver appender. If you use it this way, all the log messages will be transmitted via the API directly into the backend service that we're using to store the logs. I'm going to give it a try. We'll see how this works. But if everything works, it's going to be pretty awesome for a couple of reasons. But let's see if this is going to work. Okay, so I'm going to go ahead and restart it. Still using Spanner. We added two endpoints here, the hello endpoint, which we can say hello to, and also the hello O endpoint, which I'm going to say hello to 3 people. Right, so once this is all started, what I can do is to do a curl localhost. Let me give this a try. I'm going to hello, name is Mario's in the room, so I'm going to say hello to Mario. Oh, not clear, sorry. Whew, that was close, yeah. Curl hello to Mario, and you can see that the log message here is generated. And also, because of Spring Cloud Sleuth, you get the trace ID, the span ID. Oh, look at here. The third component here is whether you are exporting the trace or not. The reason being that by default, Spring Cloud Sleuth only captured 10% of the request for tracing. If I want to trace every single request for testing purposes, I need to set that probability to 1.0. So I'm going to go ahead and rerun this with a new configuration so that I can capture every single request. So it's going to go through the whole thing. Oh, that was a little quick. Is that too fast? I don't know. When something that works too fast in a demo, it usually means it doesn't work, right? So we're going to see. So I'm going to say hello to Mario again. And let me see here. OK, it did pick up the new configuration, so this is true. And I'm going to say hello to all of the 3 people that we listed in the method here. So I'm going to say hello to all. And you can see that we generated 3 more log messages here, Ray, Mandy, and Jisha. And every one of them has a trace and a span ID associated with it. Now, this is important because when you export the logs the right way, if every log message is associated with the right trace IDs and span ID, what that theoretically means is that when you go and look at your distributed tracing, you should be able to actually see the logs that's associated with each of the trace. Or you can go, grep for it, right? Some people would just, grab the trace ID and, concatenate all the logs and just go grep for it. So we can do it both ways. So for example, remember we added the logging starter. What that means is that all the logs now are actually available in a centralized location. In this particular case, this will be available in Stackdriver logging. And I think there is a log that we can go to somewhere along the way here. It's actually called global. So there's a global log. You can change the name of the log if you want to, but there's a global one that by default is going to be called the Spring log. And the log is going to take some time to catch up because this is actually being made via the API. And if with any log, I should be able to see the logs. There we go. So you can see all the logs are actually propagated to the centralized logger in this particular case. If I want to search for the trace ID, interesting, it's not there yet. Oh, that's because this is looking for the text, and the trace ID is actually not in the text, but this is actually stored in one of the attributes of the log entry. But what we can do, though, is we can go to the trace. So remember, we added the trace starter. What that also means is that all the traces are now automatically propagated to our trace service instead, right? So rather than managing your own trace server, this is one of the options. So we can see the traces here, and we can see very clearly that there's the O that we just made, right? There's the O log. And then we can see the different methods that we called, or the different services that we called. And then, of course, if I scroll to the right, I should be able to see even more detail about this particular call, right? And specifically, there we go. We can see the name of the controller and the name of the method. When the log message is to catch up, what this will do is to show me a little icon here called show logs, and I should be able to click on that and make that show up directly right next to the trace here. Okay, that's all pretty cool, and that's necessary to make a pretty straightforward service. Now, in case that you do want to do something with messaging, we do have something called PubSub, and that is a hosted messaging service that's available globally as well. Everything you do on Google Cloud is pretty much global by default. So for example, if I ever want to create a new topic, rather than having to create a new cluster of, I don't know, RabbitMQ or Kafka or something like that, if I want to add a messaging capability to my app, I can go ahead and create a new topic, for example. And again, these are just fully managed services for you. So for example, you can say, this is my people topic. I can just go ahead and create it. If I want to use it on the side here in this application, it's pretty straightforward, right? All you need to do is you get the drift, right? You just need to add the starter for it. And we'll automatically configure your application to be able to consume messages and send messages. Specifically, what this starter will do is to automatically create a bean called the PubSub publisher template bean. And from the publisher template, you should be able to say, I want to publish my message to my, there we go, public val, there we go. I want to be able to say, once I save the message, I want to go ahead and publish it. So I'm going to say publish. And then I'm going to publish it to people topic, which is the one I just made. And then I'm going to say message with the name inside, okay? So that's all you need to do. If you want to receive it, of course, you can use the starter for that too. So if you want to receive the thing, the messages we're getting, in PubSub, what you need to do is to create a little topic, and then you need to create a subscription. So here we have the people topic, right? For every subscriber that you want to have to receive messages, you may need to create a subscription instead. So here I'm going to create a subscription. I'm going to call it people topic subscriber. I'm going to call it subscriber. So this is all new. So from this subscription, then I can receive the messages that's coming from the people topic. Okay. Now, if I want to create a new application that will receive the messages, all I need to do is to add the GCP messaging starter in this case. I can call this demo receiver, maybe, receiver. And so I can create a new application that can receive and process messages in an asynchronous fashion very, very easily. So let me go ahead and try that. I think I got a few more minutes, yeah. So again, if I generate this app, you can see that we added the PubSub stuff. And of course, I can go ahead and create a new receiver here. Oh no, this is in Java, whoops. So what that means is I can create an application. Let me see here. It's going to be called application runner, right? Application runner, yeah. app runner. So I can do that. And I'm going to return new application runner. And then I can implement this thing right here. Now, of course, in this runner, what I need to do is to be able to receive the pops up messages. So for that, I'm going to, again, use my pops up template right here, pops up template. And then from the template, I can say subscribe to my people topic subscriber. I think that's what I call it. And then this is going to give me a new, need to create a new lambda here, in which case I can receive my messages, right? So I can go ahead and just finish this off if I want to. So first of all, every message you receive, you have to acknowledge it or NAC it, right? Because if you don't acknowledge it, then we will redeliver the messages for you behind the scenes. So if you don't want it to be redelivered, if you process it properly, then you can just ACK it. Otherwise, you can NAC it instead. What I'm going to do is just to go ahead and print this out. I'm going to say received, right? And then pops up message, get data, get to UTF string. Yeah, there we go. And that's how I can just receive messages in an asynchronous fashion. So let me go ahead and start this as well. I'm going to run both of them side by side, see if that works out well. I'm going to restart this application as well. I'm going to stop and run and see if both of them are hooked up together. Okay. So here we're listening for messages right now. This is all listening directly from the Cloud Pops Up topic or subscription. And here on the other side, I'm going to see, did I start? Yep. I'm going to send the messages. All right. This is all very, very simple and straightforward. So I'm going to say hello to everyone again. So it should generate 3 messages that we're going to send. As you can see, there we go. So we send 3 messages out. And hopefully, this is going to send it to Pops Up. And on the other side here, when the messages are propagated, we will be able to see it on this side. Oh, you tell you what, I think I did forget one thing. I need to add the bin here. Oh, that was close. Yeah. So let me try that again. Because without the bin, this application runner is not going to be discovered, and Spring wouldn't know about it. So if I add the bin, then this should take place, and there you go. There are the messages that I just sent. Right? I can do this again if I say hello to all 3 people, and you can see the other side, all 3 of them are receiving. Now we have a choice. We got this application up and running. We saw how we created with Spring and Spring Boot and using the starters, right? That's all good. But then we need to deploy it into my environment. Now I'll give you 2 choices. How many people here want to see how to deploy this into a Kubernetes cluster? Okay, about half. How many people want to see how to deploy this into App Engine, platform as a service? Nobody. Yeah, maybe 1 person. Okay, yeah. We'll do both. Well, let's do one at a time. Why is this in Chinese? Wait a second. Let me fix my keyboard first. That's not good. Yeah. Let me go back to English. There we go. Whew. Talk about exiting VI. Exiting VI in Chinese is infinitely harder. Okay. So we can do 2 things. Well, first of all, we need to containerize it. I do have a cluster created somewhere. So here I have a Kubernetes cluster. Let me see if I can see it. I'm going to get pods. I think I deploy something I was doing in rehearsal. I'm going to go ahead and get rid of it in a second. So come on, Internet. You can do this. Yeah, there we go. So I'm going to delete a demo here called the teaching note demo. So I'm going to go ahead and delete it and teaching note demo. So I get rid of this, whatever I was playing around with. So first of all, you got to build a container image. So what do you typically do? You go and write a Docker file, right? Somebody writes the Docker file, or you copy it from the internet somewhere that somebody else wrote the Docker file. We actually have this really, really awesome project called Jib, J-I-B. Ooh. Confirm my account. Really? I don't want to come. What? What? 1 second. Let me go to a guest window. Yeah, there we go. Whew. All right, so here's the project that Google actually worked on. It's called Jib. It's a really nice set of plugins for Maven or Gradle to help you build a container image without actually using Docker or writing a Docker file. It will basically examine your packaging that you specify in the POM or in your Gradle file. And if it's a jar file, will automatically create a Docker container from whatever that you are using to build a jar. And also, some of you may know, I have a full 1-hour talk on some of the best practices on how to build a Docker container image for Java applications like this one. So jib actually implemented quite a bit of those best practices so that it actually does all the layering for you automatically behind the scenes, and all without using Docker. So what that means is that if you do have a large team where you don't want people to like really have Docker installed on your application, on your machines everywhere, you can just add this plugin called jib. I'm using Maven, so it's jib Maven plugin. And you can give it the name of the target image you want to build to. So this is basically using the registry API. We're going to build directly to the registry. So what happens then is that if I go to the terminal here, if I go ahead and build this container image, I'm going to do Maven wrapper. So Maven, there we go. Maven, yeah, there we go. I'm going to do a clean and compile. And then all I'm going to do is to jib it, right? So I'm going to jib it. So what that's going to do is, well, first of all, it's going to do the clean. Oh, wait, hold on a second. So what it's going to do is to examine your pom.xml, and then it's going to see what jars do I need to include, and you will layer this properly in one of the bottom layer. However, because of this, sometimes you may have something that's scoped to be provided. If it's actually provided, that's fine. But if it's not provided, then you actually have to package it directly into your container as well. So I'm going to remove that provided. I'm going to just jib it. Okay. So again, I'm going to do a clean, do a compile. This is running a Kotlin compilation here. And then you can see this is actually containerizing my application directly into the registry. There's no local Docker build. It really just built the layers directly, and then that was done. That was pretty quick. Basically, what's happening behind the scenes is that we are generating layers for different type of artifacts that is included in your container. So for example, if all of your dependencies will be automatically pulled into one layer, all of your class files will be pulled into a separate layer, and all of your resources and the property file will be pulled into a different layer as well. So we do automatically layering for you. What that also means is that this is not a single 80 megabyte jar. Whenever you change a class, we'll only rebuild that particular layer for you. This is all done directly with jib. And now I have my my container. There it is. I have this push directly to the registry. So we can just run it. So one of the easiest way to run this in Kubernetes by doing kubectl run. I'm going to call it the voxday. Voxday is going to call it voxday, right? And then the image is going to be satanism/jib-demo, the latest version, right? Let me just run replica equal to 2. So I'm going to run 2 instances. In case one doesn't start, the other one will start, right? No. If one doesn't start, the other one wouldn't start either. Because, that's interesting. That is a little too fast. I don't know. Remember what I said, when a demo works too fast, you don't know if it's actually working or not. So, and remember what I said about the configuration for Kubernetes. It's probably the best that I don't write the logs directly to the APIs. It's probably the best that I write the logs to std out, right? So with the starter, what we can also do is to allow you to write directly to JSON. So I'm going to go log by JSON here. So this will output the log into a JSON format properly so we can pick it up from our centralized logger. So let me do that again. So I'm going to go back here, right? I updated a configuration. I'm going to do another compile, and then I'm going to do a jib build. And you can see how fast this iteration is. So I'm going to do the compile, right? I don't necessarily need to do that, but I just wanted to try it. All right, there we go. And we're building the layers, and we're only replacing the classes layer. So it's already finalizing. It's rebuilding my application. And for that, I'm done. And I'm going to go ahead and delete my voxday deployment. I'm going to redeploy this in a different name again. So I'm going to run this again. I'm going to say vox ticino, right? So there we go. And then I should be able to see my application. Ooh, that's a little bit too fast. That's way too fast, isn't it? I don't know if this is working or not. So let's see. Oh, okay, that's not bad. So we are seeing the application, and then we can expose it if we want to. Vox ticino, we can expose this deployment. We can say the port that I want to listen on is port 80, and then the target port is 8080 for that matter. And then let's see here. I'm going to expose it via a load balancer of the type called load balancer. So we can get a public IP address to see if that's actually going to work. Okay. So let me see here. Voxed, what were provided but no name selector. Let me see here. Get deployment. I think I typed a little bit too fast. So expose, yeah, there we go. Expose deployment, yeah, there we go. Whew. So what that's going to do is to get me the load balancer IP address, yeah. And eventually what we'll see is the load balancer with the public IP address, okay? So we're gonna wait for this to start. While we wait, what I'm going to do, yeah, there it is. So that's the service, and then we'll eventually get a public IP, okay? While we wait, this is what I'm going to do at the same time. What I'm going to do is to actually deploy this into App Engine as well. And the way I'm going to do it is by basically going to, we have really good IDE support. So what I can do is to just add my App Engine standard deployment here, right? So I can add it directly to my application. This will configure my app to be able to deploy into a platform as a service. I can, of course, go ahead and modify my configuration. I'm going to do this fairly quickly. I'm going to deploy into my project. I'm going to use the WAR file, and I'm going to find my project here. Yeah, very tight, very tight. And then what I'm going to do is to deploy it into a new version. I'm going to call it version 4. I'm going to route all the traffic to the newest version. I'm going to stop the previous version from running because in App Engine, we can do automatic traffic splitting for you as well. I'm going to apply this configuration, and I'm going to go ahead and deploy it. So this is the way I can deploy into platform as a service. I add the configuration via the IDE if I want to, and I press run. And this is going to go ahead and deploy everything for me into App Engine. Now, hopefully this will come up. And when you do deploy into App Engine, you also get a HTTPS endpoint. So this is running and deploying right now. Whereas, here's my app from Vox Day Ticino. Now, what's really, really scary for me is to actually see it running. So I'm going to go ahead and try it. Maybe it will be there, maybe it's not. So let me see here. Do I get to see persons? Persons? Oh, not bad. Yeah, so I basically just gypped it. Thank you, thank you. I built the app. I'm using Spanner. It's got trace. It's got logging behind the scenes. I gypped it. It became a container. I just deployed it into my Kubernetes cluster, right? At the same time, I also just deployed this into App Engine as well. So if I'm lucky, I should be able to go to my App Engine app, and I should be able to see the persons repository. Oh, there it is. So this is running on App Engine, all from the same application as well. Now, with the last 3 minutes, is the last thing I want to show you, because we do have this thing called name. Is I'm going to say hello to someone. I'm going to say hello, Ray. One last thing I really want to show you is why does all of this matter? Because not only do you get to see the trace, what you can also do is this. I'm going to go to my console, go back to my console. There's this thing called the debugger. Now, I don't know how many times people like to add a new log message to your running app, and what do you do it? How do you do it? You'd be like, oh, I got to go check out the code. I need to go back to the app. I need to add a new log message, and then I need to rebuild it, right? I got to rebuild everything, and then I had to push it to my production environment. And how many people here can deploy to production in 5 minutes? Yeah, no? 10? 20? Yeah, 1 hour, right? So if you do actually need to troubleshoot something, this is what you can do. Yeah. So I can come here into my debugger. I can see, in this case, my App Engine app. This works well with Kubernetes apps as well. I can add my source code, which I just created. So I'm going to select my local file. And this is in demo GCP. I'm going to select my Kotlin source. I'm going to upload it, upload this file. I got 2 minutes left. And then, if I want to add log messages for debugging, somebody code this a, what do you call it? Oh, am I in the wrong thing? Hold on a second, check. There we go. Yep. So let me do this deploy. Add source. Yep. I'm really short on time, so let me just show this very quickly. I'm gonna add this file. Yes, I got 2 minutes. There we go. Whew. So this is what somebody told me. So you can see the source code I just wrote. Somebody told me a little trick called the debugging with a binary search log. So basically, a binary search logging or logging searching is like you go from the top, like I'm here, right? And then you put another log message at the very end, so you know that I'm done. And if anything goes bad in the middle, you add like somewhere in the middle and say 1A. This should work, right? Or something like that, and you can add it. Now, every time I come back here and say hello, it's going to have all of these log messages automatically propagated to all of the running instances. And you can go back to the centralized logger to see it. You can see all the messages if you want to. If I do the reload, there we go. So you can see very quickly the log message now show up directly. And if I scroll up here, I can see I'm here, and I'm done, and the one in the middle as well. And of course, you may actually want to add a production debugger. And the last thing I want to show is that you can do that too. So I can add a production debugging here. And if I do a refresh, what we're going to do is to be able to capture the stack that's coming through this line of code at that very instance. And you can actually see all the running variables inside of this state without actually stopping the world, right? So what you saw is when I did a refresh, there's no blocking. I didn't have to step through the code. I get all the debugging data if I want to. And that is pretty much all the time that I have. And so thank you very much for your time. And if you have any questions, I will be outside. Okay? Thank you.